Let's pick up where we left off on the last video. We were looking at some implicit differentiation and looking at some examples. And we've got, I think, 3 more examples here for us to look at. And as usual, what I'd like you to do is to try to write this down now that you've seen a few examples and see if you can do this next one on your own and then come back. And if you remember, what we're trying to do is I give you a formula for an implicit function. The graph up here is for the last one. And then, for example, graph it, and we want to graph a tangent line at a specific point on the curve. Here's from the last example. So here's a new example down here. 3x minus 4y over 5x minus 2y equals negative xy. And we want to find the tangent line at 1, negative 1. So we're going to check to make sure that 1, negative 1 actually is a point on this original graph. We're going to find the formula in general for dy over dx by using implicit differentiation. We're going to use that formula to find the slope of the tangent line at that particular point, and then finally the equation of the tangent line. And then, like you see up here, for this function we'll graph the original relation and the tangent line. I said the function, but these are not functions. They're implicit relations that are not functions. Okay, so if you haven't done it already, why don't you go ahead and do this one now? Press pause. Okay, let's find the derivative, dy over dx. Okay, to do that, we start by writing down the original equation just exactly as it is. Now, in this case, it might have been easier if I just multiplied both sides by 5x minus 2y. That actually probably would have been, and in distributing that probably would have been actually a better approach to this, but this gives us some practice doing the quotient rule, so why not? Let's just do it this way. So here we're going to use the quotient rule, so it's the bottom times the root of the top minus the top times the root of the bottom over the bottom square. On the right side, that's for the left. For the right side, we'll use the product rule. So it's the first, negative x, times the root of the second, which is dy over dx, plus the second, y, times the root of the first. Root of negative x is just minus 1. Minus 1 times y is minus y. Over here, let's see what we can do. The derivative of 3x is 3. The derivative of negative 4y is negative 4, but dy over dx, because the y and the x don't match, it's like you did a substitution. You have to use the chain rule there. The derivative of 5x is 5. The derivative of negative 2y is negative 2 times dy over dx. Now what I did is now I'm finally multiplying both sides by 5x minus 2y squared to get rid of the fractions. I probably could, like I said, it probably would have been easier if I just multiplied both sides by 5x minus 2y to begin with. But anyway, here's what I did. That cancels this out, leaves the numerator basically just the same, and then on this side introduces the 2 factors. On the left, I'm going to use FOIL and multiply this out. 5x times 3 is 15x. We got negative 20x times dy over dx. That's for the outer. The inner is negative 6y. And the last times last is positive 8y times dy over dx. So those 4 terms are from this too. Then we get these 2, but then don't forget we're going to distribute a minus. So 3x times 5 is 15x, but that negative makes it negative 15x. The outer product is negative 6x dy over dx, but the negative out front makes it plus 6x dy over dx. The inner product is negative 20y. That minus right there makes it plus 20y. And then for the last times last, it's positive 8y times dy over dx, but that minus makes it a minus 8y dy over dx. And over here, I distributed this square times each one of these. So it's negative x times 5x minus 2y squared times dy over dx, minus y times this same factor. Now I need to get the dy over dx's together, so I'm going to take this. I've got them on both sides, so if we want to get them all, most of them are on the left. Let's just get it over there. So I need to get rid of this 14y. It doesn't have a dy over dx. So add a negative 14y to both sides, gets rid of that, puts it on the right. Here, this one has a dy over dx, so I need to add its opposite to both sides, which is a positive, parentheses 5x minus 2y, close parentheses squared, times dy over dx. And so we're at this point. Now, over here on the left, I'm going to factor out a dy over dx, which leaves negative 20x plus 8y plus 6x minus 8y plus x times this polynomial, this binomial squared. I think maybe the next thing we want to do is, well, a couple things. We can combine some like terms here. Negative 20x plus 6x is negative 14x. 8y plus a negative 8y is 0, so that goes away. And then I want to expand this out. 5x minus 2y squared. You square the first, is 25x squared. Square the last, that's plus 4y squared. Multiply here is negative 10xy, and double it's negative 20xy. Still got our dy over dx out here. And this squaring is the same thing. Multiply the y through here on the right, and we got negative 14y. And then the negative y times 25x squared is minus 25x squared y. Negative y times negative 20xy is negative 20xy squared. And negative y times 4y is negative 4y cubed. And distribute the x over here, which you can see all the powers of x go up 1. Divide by this coefficient here, and now we have our formula for dy over dx. Verify that the point is actually on the curve by taking xy equals 1, negative 1, putting it in the original equation, 1 for all the x's, negative 1's for all the y's. Let's do the right side. Negative 1 times negative 1 is positive 1. 3 times 1 is 3. Negative 4 times negative 1 is 4. 5 times 1 is 5. Negative 2 times negative 1 is 2. 3 plus 4 is 7. 5 plus 2 is 7. 7 divided by 7 is 1. And 1 equals 1, so it checks. Let's see if I can. Okay, now let's find the equation of the tangent line. Go back to our formula that we had, which is this kind of complicated rational expression in x and y, and plug in x is 1 and y is negative 1, which you see that I've done here. And for example, that y is negative 1, that x is 1, there's an x of 1, y negative 1, and so forth. Multiply all this out. Negative 4 times negative 1 is 14. Negative 14 times negative 1 is positive 14. Negative 25 times 1 squared times negative 1 is positive 25. 20 times 1 times negative 1 squared is 20. Negative 4 times negative 1 cubed is a total of 4 negatives altogether. Makes a positive 4 there. Negative 14 times 1 is negative 14. Negative 20 times 1 squared times negative 1 is positive 20. 4 times 1 times, well, negative 1 squared is also 1, so that's 4. And 1 cubed is 1 times 25 is 25. 14 plus 25 plus 20 plus 4 is 63. Negative 14 plus 4 plus 20 plus 4 plus 25 is 35. And notice these both have a 7 in common. 63 is 7 times 9. 35 is 7 times 5. The 7's cancel, leaving you 9/5. So the slope is 9/5. And the equation is y equals 9/5, that slope, times parentheses x minus the x coordinate, plus the y coordinate. It should be x minus a negative 1. Yeah, x minus a negative 1. Right. X minus a negative 1 is the same as x. No, x minus a positive 1. So that's x minus 1. And the y is negative 1. Is that what I wanted? Yeah, that's right. Okay, so hopefully that's what I've got graphed here. Is it x is negative 1? Oh, it's not the one I have graphed, but it turns out the slope is the same. Let me fix turns out these tangent lines are actually parallel, so it worked out. Let me go ahead and fix that like it should be. Okay. So I've got to get back to find my original formula here. Okay, let me get this where I can, you can't see it, but I can. Okay, so I'm typing in y equals parentheses 3x minus 4y parentheses divided by parentheses 5x minus 2y, close parentheses, equals the opposite of x. I need to put in a times y. Alright, this should be my original graph. Whoops, let's see. Oh, there's no y equals. Sorry. There we go. There's the correct graph. Let's maybe zoom in a bit here. Okay, and then the tangent line that we should have, let's see if I get the right tangent line now. Going back to here, the tangent line we came up with, the correct one is 9/5 x minus 1 minus 1. So that one does have a y equals. Y equals parentheses 9/5 parentheses x minus 1 close parentheses minus 1. Now if we do this right, it should go through the point 1, -1 where the graph goes here, and it should be tangent at that point. And sure enough it is. So that looks good. So let's copy that graph, replace the one that I had here, and I didn't notice it before because it turns out the tangent line up here at -1, +1 turns out to have the same slope. So when you zoom in, you get that. Okay, let's go on. All right, here's another one for you to try. Okay, sine of pi x over y plus 1 equals cosine of pi x squared plus tangent of pi y at 0, 2. Okay, do this one yourself and come back and check it. Press pause now. Okay, to find the derivative, let's go through this. Write the formula down just like it is. Take the derivative of both sides with respect to x. This is derivative of sum. The derivative of one part is 0. Derivative of sine of u is cosine of u times the derivative of u. We'll get to that in a minute. On the right side, derivative of the sum is the sum of the derivative. Derivative of cosine of w is minus sine of that w times the derivative of w plus. Now we got the derivative of tangent of v is secant square of v times the derivative of v. Let's see. Let me start back here at the left. The derivative of pi x over y, I'm going to think of pi x over y as pi times x times y to the -1 and use the product rule. So first is pi x, the second factor is y to the -1. So it's the first times the derivative of the second, which is -1 y to the -2 times dy over dx. Plus the second, y to the -1 times derivative of the first, derivative of pi x is pi. And there's a times right here between cosine and that, so we need a times here, which is implied, but we need these parentheses here to make sure it's times both of this. We may end up distributing here in a minute. Okay? We will end up distributing. Now over here we still had a couple derivatives to do. The derivative with respect to x of pi x squared is 2 pi x. The derivative with respect to x of pi y is just pi, but then times dy over dx. So I moved this pi in the front here. I moved the 2 pi and the x in front here with the minus. And I distributed here and make this cosine of pi x over y times pi times x. And then this is the negative went out front, and then the y, the -2 becomes y squared in the denominator. And all that's times dy over dx. Plus, when we multiply the cosine of this thing times this, we get pi times cosine of pi x over y. And then that's over y. Now again, we want to get the, I think let's see, what did I do next here? Next, I decided to, get the dx, dy over dx terms on the same side. So this one, I subtracted this one here. So minus pi secant square pi y times dy over dx to both sides. That gave me the first term here. I still got this first term. Well, the original first term is still here. I want to get rid of this term here by adding its opposite. So that goes here at the end with the opposite sign. And this term stays where it is. Then what I want to do here is I got some fractions in here. I want to get rid of them. And it turns out everything has a pi. So if I divide by pi, that'll just get rid of all those pi's out front. And they all have, everything has a negative. So we're going to get rid of the negatives by multiplying by a negative. And we're going to multiply by y squared. Now this is going to have a result of simplifying it a bit. When we multiply here, the pi's cancel, the negatives cancel, and I get y squared times secant square of pi y times dy over dx. Plus, when I multiply here, the negatives cancel, the y squares cancel, the pi's cancel, and I just get x times cosine of that thing there times dy over dx. On the right side, when I multiply here, the negatives cancel, 2 is still there, the x is still there, the pi cancels, and we've got a y squared times the sine. Plus, here, the 2 negatives makes a plus. The y squared and the y cancels to just a y, and the pi's cancel all together gives us this. So just cleaning that up a bit. Now over here on the left side, everything has a dy over dx multiplied by it, so I can factor that out using the distributive property and then divide by both sides by this coefficient, and here is the answer here. Secant square is actually 1 over cosine square, so I'm going to get rid of that and make everything just sines and cosines as far as the trig functions by multiplying top and bottom by cosine square of x. When I multiply that by the secant square, that cancels, just leaving me y square. Of course, that bumps this power up to 3 on this cosine because we had to distribute. Likewise, this one bumps up to 3, and this one now has a cosine square term as well. Or we could have maybe left that factored out in the numerator. But anyway, there's multiple ways we could write it. But there's the derivative. We see that 0, 2 really is on the equation, satisfy the equation by taking it and plugging in this original equation, plugging 0 for x here, here, and 2 here and here for y. Let's see what we get. 0 times pi divided by 2 is 0. Sine of 0 is 0, plus 1 is 1. 0 squared is 0 times pi is 0. Cosine of 0 is 1. 2 times pi is 2 pi. Tangent of 2 pi is 0. And we get 1 equals 1, so it does check. To find the slope of the tangent line, we take our formula for the derivative that we came up with. Kind of complicated there. But we just plug in 0 for x and 2 for y. A little bit of simplifying the algebra and trig here. 2 times 0, well, this has a factor of 0, so this whole mess here is 0. And 0 times pi is 0 divided by 2 is 0. Cosine of 0 is 1. 1 cubed is 1 times 2 is 2. This is 2 square is 4. And again, this is cosine. This is 0 in here. Cosine of 0 is 1. 1 cubed is 1. But then this 0 here makes it 0. So the top is 2. The bottom is 4. That reduces to a half. So it's y equals 1/2 x minus 0 plus 2. With 0 here, we might as well write it as y equals 1/2 x plus 2. And here's a portion of that graph. All of this blue is part of that original graph. And there you see it does go through the point 0, 2, and you can tell that it is a tangent line there. And then I think I have one more example that I'd like you to do here. So see if you can do this one. Arctangent of x minus pi over 4x equals xy squared minus 4 cosine of pi y at 1, 2. If you haven't done this yet, press pause now. Okay, hopefully you're back. Now let's take a look at what we have here. We have, there's our original equation. Take the derivative with respect to x at both sides. Derivative of arctangent of x is 1 over x squared plus 1. The derivative of minus pi over 4 times x is minus pi over 4. Here we use the product rule. First is x times the derivative of the second, which is 2y. So I'll write that as 2xy times the derivative of y. Plus the second, y squared times the derivative of the x. The derivative of the x is just 1. Then here we have derivative of cosine of something is sine of that something times the derivative of the something. The derivative of that inside is just pi times the negative 4y. I'm sorry, the derivative of cosine is minus sine, so that brings this minus to a plus. And then we have the dy over dx. The dy over dx stuff's already on the right side. Just subtract y squared from both sides. Get it over here. I put it in the middle term. And then factor out the dy over dx. Divide by the coefficient. And we get this. Now, I'm going to clean it up a little bit because I've got fractions inside of fractions. So I'm going to multiply both top and bottom of this fraction by 4 and an x squared plus 1. This distributes. The x squared plus 1 cancels. Leaves you a 4 there. Here we get a 4, a y squared, and an x squared plus 1. Here the 4 cancels, and we get a minus pi times x squared plus 1. We could do some distributing or whatever here, but I'm just going to leave it like that. And the denominator, I'm just going to basically leave it like that. The 4 times 2 is, well, I'm going to factor 2 out of this, which is times that 4 is where the 8 comes from. And then these went down to 1 and 2 here. So there's the derivative formula. Make sure that the point really is on the function, or the not a function, but on the relation, on the graph. Put in 1 for x and 2 for y. The arctangent of 1 is pi over 4. Pi over 4 times 1 is pi over 4. Pi over 4 minus pi over 4 is 0. 1 times 2 squared is 4. 2 pi here, and a cosine of that would be 1 times negative 4 is negative 4, and 4 minus 4 is also 0, so that does check. Here's the equation of the tangent line. Take the derivative formula we came up with and put, this should say 1, 2, 1 for x, 2 for y, which we've done here. And let's simplify a little bit. See, we had a 1 here for x, so that's 1 squared is 1, plus 1 is 2. We had 2 for y, so this is 2 squared is 4, times negative 4 is negative 16 times the 2 is negative 32. We still got the 4 there. 1 squared is 1 plus 1 is 2 times negative pi is negative 2 pi. I can combine like terms here. 4 minus 32 is negative 28 minus 2 pi. In the denominator, I've got a 1 squared is 1 plus 1 is 2 times 8. Well, just left it there, and then got the 8. I got 1 times 2 here is 2. Sine of 2 pi is 0, so this term is 0. This is 2 times 2 is 4 times 8 is 32. And I can divide out top and bottom by 2 to reduce, or multiply top and bottom by half. 32 times a half is 16. A half of 28, negative 28 is negative 14. A half of negative 2 pi is negative pi. And so there's our slope. One way to write it anyway. And so we see there's our slope, parentheses x minus 1 plus 2. And you see that it, in fact, that graph does go through the point 1, 2, as does the original graph, which is the blue graph, and there's your tangent line there. That's going to pretty much finish us up. This semester, I'm using Stewart's Early Transcendentals Calculus book, but you should read whatever book you're using. Read the corresponding sections in your textbook. So the sections that correspond to what we're doing in this whole playlist are 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, and 3.11. And since you're reading this online, hopefully, notice that Stewart also has videos embedded in his, and many, many more examples and more explanations. So try to do that. Here are Dr. Price's videos, Khan Academy videos, and Richard Delaware's videos that I would also suggest as good options for you as well.